Hi everyone. I'm going to introduce our latest research titled Neptune-X, Active X-to-Maritime Generation for Universal Maritime Object Detection. I'll present our work in 4 parts. First, the introduction. Maritime object detection is really important for navigation, safety, surveillance, and autonomous operations. But it faces 2 main challenges. First, models don't generalize well because of inherent imbalances in existing maritime datasets. Collecting and annotating this data is expensive and labor-intensive. Unlike land scenarios, gathering data from different sources like ships, UAVs, and coastal cameras takes a lot of resources. And manually drawing bounding boxes makes it hard to scale up datasets. Second, current datasets show big differences in training difficulty across various attributes, like imaging conditions, viewpoints, water environments, and object types. To tackle this, we propose Neptune-X. It's a data-centric generation selection framework designed for robust maritime object detection. Now, the second part, our method. Our approach consists of 2 main parts, X-to-Maritime image generation and an active learning-inspired data selection strategy. From the generation side, we developed X-to-Maritime. It's a multimodality conditioned generative model that creates diverse and realistic maritime scenes. We use stable diffusion as the backbone and frame the noise prediction as our training objective. A key innovation is our bidirectional object water attention mechanism. It explicitly models the interactions between objects and their water surroundings, which makes object placement look more realistic and coherent. For the selection part, Neptune-X uses an attribute-dependent active sampling strategy, AAS. This prioritizes synthetic samples that are most beneficial for boosting detection performance. The strategy is guided by what we term attribute-related training difficulty factors, ATDFs. These factors estimate how hard a sample is to learn from, based on different semantic attributes like viewpoint, object category, and environmental conditions. Next, let's move on to the experimental evaluation. To advance research in this field, we created the Maritime Generation Dataset, MGD. It's the first dataset specifically designed for maritime image generation. MGD contains 11,900 samples gathered from multiple sources and devices. Each sample is richly annotated with bounding boxes, captions, and water masks. It comprehensively covers 5 object category, viewpoints, and various water environments and imaging conditions. This diversity makes it a valuable benchmark for maritime scene generation. First, we tested the quality of our generated images. The results clearly show our method outperforms others on all evaluation metrics. As you can see in Figure 4, while other methods often make mistakes, our approach, thanks to the BioWATN module, creates much more realistic and harmonious maritime scenes. We also confirmed the importance of each component through ablation studies. Then, we tested how this synthetic data improves object detection. Adding our data to the training set gave a significant boost to various detectors, from YOLO models to open vocabulary ones. Crucially, our active sampling strategy was key here. It efficiently selects the most valuable data, which not only boosts overall performance, but also reduces bias, especially improving accuracy on previously difficult attributes. This leads to greater gains with less data, as shown by the saturation effect in our charts. Finally, I'll summarize the work presented in this paper. In summary, our contributions are threefold. First is the X-to-Maritime generative framework, which creates realistic maritime scenes through its bidirectional object water attention mechanism. Second is our active sampling strategy, which dynamically selects the most valuable synthetic data. And third, we've built the Maritime Generation Dataset, MGD, as the first benchmark for this field. Thank you for your attention.